living forever and living for tomorrow are identical concepts. I really want to live tomorrow, and when tomorrow arrives, I'm imagining I probably want to live tomorrow's tomorrow. And I don't know when that ends, but I'm signed up for tomorrow.
Or there are these concentrations of people who are not only living a long time, but they're living a very robust old age.
To demand, then separating your brain out, putting it in lights already, and putting it in a jar. They're doing that with life. There are ways we can prolong the life of other animals, but they don't live forever. They just live longer than they otherwise would have. So I think we're much closer to that manipulation of the genome than removing the brain from your skull and sticking it in a jar.
Huh. Living is good, isn't it? Well, for me, it is. If suffering isn't included, but we're not talking about in this video. Not talking about despair, but what I'm trying to say is I don't want to die. I want to experience everything, enjoy, create, do the stupid things that I did when I was a kid. Whether by playing video games, Undertale, Stardew Valley, Minecraft, or Steak War 2. Or read a book, listen to music, exercise, or making new hobbies. Basically, I wanna create more memories and not thinking when I'm gonna die, no matter how cringe or embarrassing it was. Because I don't have any money, like literally at all, like zero. You can literally see it everywhere in my video. But I have invested a lot of my time learning why we age or how to at least slow it down, so I can at least teach you something. So I guess let's start. Now let's go for a quick overview. Basically, humans are long-lived creatures. So I often joke that I want to live even longer. Like literally decades. We literally live decades, 7 decades or 8 decades, maybe. But statistically, and archaeological evidence shows that life expectancy today is markedly higher than during the hunter-gathering or medieval periods like 10,000 years ago or 500 years ago or 1,000 years ago. So basically, during the hunter-gatherer era, humans faced constant threats from predators, starvations, and infectious diseases. Like, we're literally on a high-stress environment in the past, not now. Life was physically demanding and infant mortality rates were high. Even for those who survive childhood, the average lifespan rarely exceeds 30 to 35. While some individuals often lives to their 50s or 60s, which were rare, but sometimes it happens. But in contrast, modern humans enjoy far greater longevity thanks to scientific and technological progress, like vaccination, antibiotics, advanced medical treatments. So it's basically thanks to technology that we live longer. And also improved nutrition allow people to survive childhood illnesses and live into their 70s, 80s, or beyond. Modern sanitation, safety standards, and disease prevention have further reduced early mortality, while social and economic stability support longer, healthier lives. Yet, despite these advances, our biological potential for longevity remains much as the same as that of our ancient ancestor. So yes, our DNA, telomeres, and cellular repair mechanisms are nearly identical, found up 10,000 years ago of the agricultural era, giving us the same intrinsic capacity for health and renewal. We basically have the same telomere length as those ancestors in the past. But you may ask, different people have different lifespan, and yes, genetics can have a cause, but it's not like the different variants, like a person living 10 years, another living 1,000 years old. We still have the same or less genome as our ancestors. Speciations, the emergence of new species, is extremely long time. So lifespan today comes from more about how the genes are expressed, their repair efficiency, metabolisms, and most of all, the environment. So basically, in summary, different people get damaged at different rates, causing them to age slower because their stem cell reserves are basically dividing slowly. Or they just have good genetics. I don't know. Basically, it's randomized. One person can have a telomere so short, but they live long because their stem cells divide slowly. Or someone who has extremely long telomeres, but like 15 kb, but they always smoke, drink, and cause damage to their organs. So their telomeres are basically shrinking and shrinking due to maintenance to their organs. I'm yapping too much. Alright, I'm gonna tell you the four horsemen of aging. The second is telomeres. It is basically the protective end caps of your DNA in your cells that tells your cells, the stem cells we're talking about, specifically how many times your cell divides. The average telomere length is about 10 or 15 kb. That's kilobyte in measurement. Um, every time those stem cells divide, it loses about some base pairs. I mean, those stem cells, not us. I mean, it is at 5 kb, the cells basically become retired and become senescent. It becomes a useless cell, producing inflammatory distress signals because specialized cells like muscles, brain, and osteocytes don't divide. But you may ask, Jeter, if everyone has stem cells, why do people who got hurt, burnt, or get cut have scars? Or pulling out your hair, plucking them out? Basically, it damages them, or cutting a muscle part doesn't regenerate them. Because the signal in those stem cells have completely disappeared. It's like you have a blocks of Legos and suddenly the instruction manuals on the part of your cells to build like a computer had disappeared. The biochemical signal that tells them what to build and how to arrange themselves is gone. That's why, so instead of reconstruction the complex structures, they just stack whatever they can to block the damage. Basically, stem cells need guidance, or else they won't turn or differentiate into specialized cells like muscle cells, bone cells, skin cells, ciliated cells, Crohn's, Coats, brain cells, or any cells that you can think of. So the stem cells will just stay there and die off, differentiate randomly, or they just overgrow, but that won't happen in normal cells. Like tumors, they just keep dividing without directions. A overgrown blob. Well, that's cancer mutation. Let's talk about mutation itself. Mutation is literally when the genetic code inside your cell changes. It's inside your nucleus or the central heart of your cell where the instruction manual that tells them how to survive, function, and build their structures. Basically, every time a single cell divides, it has to copy the manual word for word. But sometimes a line gets skipped, duplicated, or a new one gets added by mistake. Those changes can mean many things. Some are harmless and go unnoticed. Some are dangerous, breaking the system and making cells behave in way they shouldn't. And a few might actually help the cell adapt to new environmental stresses. Basically, evolution happening at a smaller scale. You could say mutation is like cell evolution. It's how all life changes and adapt through time. But the ratio between good and bad isn't fair. The bad outweighs the good by a lot. Most mutations don't make something stronger, they make it weaker, unstable, or self-destructive. There are few factors that can accelerate or decelerate mutation. Some are like when you go into sunlight, the intensity of the UV light can literally damage your cells, taking off a part of it. Sometimes those cells can repair it and sometimes they don't. That's where tumors happen. Others are like reactive oxygen species or oxidative stress. When you exercise, running, or doing a marathon, your cells literally burn energy in the mitochondria, making more oxidative stress. Some are like X-rays, gamma rays, they also can damage your cells, DNA, chemicals, viruses. Basically, viruses actually enters your cells to replicate themselves to make more of themselves, or just replication error of every time a cell divides. Or chronic inflammation. There are many types: toxins, minerals, and other types. The third one is mitochondrial decay. Basically, as you age, your mitochondria starts to get old. And yes, mitochondria literally have their own DNA, separate from your nucleus. So technically, your nucleus and your mitochondria are aging on the completely different schedules. That's why all mitochondria end up causing more oxidative stress and producing less ATP for your cells. Basically, they're dying. Even if your telomeres are so long, like 10 times as long as normal, mitochondria doesn't have telomeres in your cells and will continue to age. So we have to find a way to stop it. It divides like bacteria that multiplies whenever. But that makes me question, why doesn't mitochondria have cancer? Do they? Do they? Do they? And the last one of all, protein turnover is one of the key mechanisms and the last horseman of aging. Protein turnover is the mechanism that keeps our cells functioning properly. The cells in our body constantly maintain and recycle proteins, lipids, breaking down damaged or misfolded proteins to prevent them from causing harms. However, this process is not perfect. Sometimes proteins accumulate or are not efficiently removed, which can cause cellular damage. Misfolded proteins, let me see, such an example, prions, are a well-known example. They can resist normal degradation and accumulate, becoming like toxin, leading to diseases. So maintaining efficient protein turnover is therefore essential for longevity and overall health. And that is all. That's the four horsemen of aging: mutation, telomeres, mitochondrial decay, and protein turnover. Now you know the basic part of aging. Now we have to find a way to stop it. So if the environment was perfect, no oxidative stress, no telomere shortening, and perfect protein turnover, and your somehow mutation was stopped, you're immortal. Yippee! Now we just have to find a way to get it, or somehow slow it down, aging. But before we dive into hormesis or longevity-related effects, compounds like ergothioneine accumulate in the mitochondria or nucleus in the cell where oxidative stress is high, acting as an antioxidant, but not like vitamin C. We really need vitamin C for collagen support and absorption of minerals like iron. Green tea can make your DNA more rigid and activate repair factors. Turmeric increases antioxidant in the body, Those two are examples of hormesis. Or astragalus root. Except I'm sick right now. Sorry about that. This video has been staying for so long, like 2 weeks now. So basically, you've seen me, the life of me of 2 weeks. That's funny, right? Now, that's astragalus roots, which hypothesize that it can activate telomeres or maintain or extend it. Other compounds like creatine, QQ10, or bacopamoner also have beneficial effects. But before considering any of these, you need to maintain your essential nutrients first. I'll talk about this the rest about another time because this is really already getting long. Now, proteins are the building blocks of your cells. They repair tissues, recycle components, and make enzymes. Hormones, antibodies, these are the nine essential amino acids we can, which you can get from meat, eggs, legumes, soy, quinoa, and nuts. Fat functions similarly to carbs as an energy source, but more importantly, they maintain cellular flexibility and help structure and help absorb and fats help absorb fat soluble vitamins like turmeric or vitamin E, as well as compounds like astragolicides. Fats are also essential because like omega 3 or omega 6, which are unsaturated fats which your body needs. The omega 3 supports the brain structure, flexibility, and integrity, heart, and reduce inflammation. Omega 6 support growth, skin, and hair. Saturated fats provide energy. Monounsaturated fats help with heart health. An energy source. You can find this. You can have good sources include sardines. They have extremely low in mercury because they're extremely small fish, but have extremely high omega 3. So it's safe to eat daily. Or olive oil and avocado to get the omega 6. The carbs are also a body's main energy source. The body can survive without them if you have sufficient protein and fats through converting protein to energy is inefficient. That's why some people eat a lot of calories from meat yet remain lean. Finally, water is crucial. It transports nutrients, maintains cellular fluidity, regulates temperature, and supports chemical reactions in the body. Now let's talk about the micronutrients. Now for the micronutrients like vitamins and minerals, which you need only small amounts, but extremely crucial. You can literally not survive without it. Vitamin A, vision, skins, vitamin D, calcium absorption, bone health, vitamin E, antioxidant like vitamin C, vitamin K, blood clotting, bone health. But also vitamin E is fat soluble, so it literally integrates in your fats. So cell protection. Vitamin C, an antioxidant, collagen, an immune regulator. The essential vitamin B1, which enables energy metabolism. Vitamin B2, vitamin B3, energy, DNA repair. Vitamin B5, vitamin B6, vitamin B7, vitamin B9. Vitamin B9, which supports DNA synthesis, cell division, and vitamin B12, non-function, blood formation. And vitamin B7, vitamin B6, and vitamin B5, 1, 2, all those are just for metabolism. Now, for the minerals, there are two types. The macrominerals, where you need a ton of them, like not like a kilogram of them, but you need them. Major ones. Calcium, which bones, muscles, nerves. Phosphorus for bones and DNA. Magnesium, which is needed for enzyme reactions. Later, there are hundreds of things that can use magnesium in your body. sodium, fluid balance, potassium, nerve muscle, chloride, fluid balance, sulfur, amino acids, and trace minerals which you need a tiny amounts. Iron, oxygen transport, zinc, immune, DNA synthesis, copper, enzyme iron metabolism, manganese, and enzymes which helps the bones formation, iodine, the thyroid hormones, selenium, an antioxidant, fluoride, which for the teeth and bones, chromium, blood sugar, molybdenum, enzymes which used for antioxidants in your body, that's glutathione. Now that's about all. Other essentials like fiber is just for digestion and phytonutrients or electrolytes. And that's about all. Thank you for watching my video. Thank you so much. And I guess I'll see you next time. See ya.